Welcome to the ffcbmd of Wandering Chemistry classes. Today's topic is radioactivity. Radioactivity was discovered by Henry Becquerel in 1896. He found that crystals of potassium uranyl sulfate possess certain peculiar properties. The photographic plate flashed near the salt in the dark were affected, indicating that some invisible penetrating radiation similar to that of X-rays are continuously emitted from this substance. He subsequently found that not only potassium uranyl sulfate but also other uranium salts possess the same property. The rays emitted by such substances are able to ionize gases, penetrate through thin metal sheets, and produce luminosity in zinc sulfide. Substances which emit such active rays were called radioactive, and the phenomenon was known as radioactivity. Later on, later on, Madame Curie in 1902 found that pitchblende, an uranium mineral, was far more radioactive than equal amount of uranium itself. This led her to conclude the presence of some highly radioactive elements in the mineral. Her prolonged efforts in separation resulted in the discovery of the element radium, which possesses radioactivity several million times to that of uranium. At present, over 40 natural radioactive elements are known. The radioactivity radiation emitted by these elements are found to consist of first alpha particles, second beta particles, and third gamma rays or photons. Now let's define radioactivity. The phenomenon of a spontaneous emission of powerful radiation exhibited by certain unstable nucleus is called radioactivity. Let's know some general properties of radioactivity. First, the radiation emitted by radioactive substances are found to possess a high penetrating power. Second, affect photographic plates. Third, ionized gases. Fourth, cause scintillation on fluorescent screens. Fifth, develop heat. And sixth, produce chemical effect. Next, as the radiations are given out, new elements are formed in an irreversible process, each element having its own characteristic radiations. Third, the emission of a radiation is spontaneous and is unaffected by external agencies like temperature, pressure, and chemical combinations. And the last one, the emission is not instantaneous but prolonged, that is, delayed action extended over a certain period of time, otherwise it cannot have been discovered at all. Now, nature of radioactive rays. The rays emitted from such substances were later shown to be heterogeneous in character. Their composite nature was investigated by Rutherford in 1902, who subjected these rays to an electric field and magnetic field and found to consist of three types of radiation: alpha, beta, and gamma rays. These rays bending towards the negative plate is shown to consist of positively charged particles. This is called alpha particles. Those bending towards the positive plate were found to consist of negatively charged particles, which were called beta particles, and the rays going undeflected, being neutral in character, is called gamma rays. Note that alpha, beta, and gamma, alpha and beta beta plus emission. Nuclei which have excess protons, such nuclei found in artificial radioactive isotopes, instead of emitting electrons, decay by emission of positrons. We assume that in case of beta plus decay, a proton inside a nucleus transforms into a neutron and positron as given below. H sub 1 sup 1 tends to 0 n sub 0 sup 1 plus E sub plus 1 sup 0 plus nu.